Good evening, and welcome to Nighttime Science, where we drift gently through the mysteries of the universe, discovering the soothing and awe-inspiring truths that lie hidden in the stars, in the vast stretches of space, and within the endless possibilities of our world. Tonight, we embark on a quiet journey, far from the noise and haste of daily life, into the comforting embrace of the cosmos. Imagine for a moment that you are floating in the stillness of space, weightless, suspended in the quiet. The universe is a place of eternal motion, yet here, in this moment, everything is still. The stars blink silently, their light traveling across time to reach your eyes, and the endless void stretches in every direction, an invitation to relax, to breathe deeply, and to let the universe wash over you like a gentle tide. Tonight, we will uncover soothing facts about the universe that you've likely never heard before. Facts that will fill your mind with wonder and your heart with calm. As we glide through the wonders of space, we'll explore how the universe breathes in rhythm with the Earth, how the stars have their own quiet stories to tell, and how the smallest particles in the cosmos work in harmony to create the vast and intricate web of existence. The universe is not just vast in size, but deep in meaning. Every planet, every star, every galaxy has a story to share, if we are quiet enough to listen. It is said that the stars are the whispers of the past, their light carrying messages from millions of years ago. When you gaze at the night sky, you are seeing the universe as it was, not as it is. In a way, we are time travelers, glimpsing the ancient past with every look upward. As we begin our journey through these calming facts, I invite you to relax. Let go of the day's worries and let your thoughts drift gently, like the stars in their celestial dance. Take a moment to close your eyes, breathe deeply, and let the calming presence of the universe fill your being. If you find peace in this quiet journey, I encourage you to take a moment to like this video, subscribe to Nighttime Science, and share your thoughts in the comments below. By doing so, you're helping this peaceful space grow, allowing others to discover this calm, cosmic experience as well. Every like, every comment, every subscription is a small ripple in the infinite ocean of the universe, connecting us all as we float along together. Now, let us begin. Take another deep breath, and as you exhale, feel yourself sink deeper into this peaceful moment, surrounded by the infinite expanse of the universe, waiting to unfold its secrets to you. The universe, in its infinite vastness, holds within it the greatest mysteries known to humankind. It is not just a place where stars shine and galaxies spin, it is the very fabric of reality, stretching far beyond our comprehension. When we try to grasp its enormity, we are often left with a sense of awe, for the universe does not simply exist in a way we can fully perceive. It hums with life, energy, and secrets that we are only beginning to understand. Its expanse is beyond the reach of our wildest imagination, and yet, in a strange way, it feels like home. The universe is always there, like a slow and rhythmic heartbeat, a constant companion in the infinite quiet. Imagine for a moment that you are floating in the stillness of space. You are suspended in nothingness, and yet everything is around you. There is no up or down, no direction, and no end. The universe is not simply a collection of stars and galaxies, it is a vast, breathing organism, expanding, contracting, growing, and transforming in ways that we are just beginning to understand. The very air you breathe, the very atoms that make up your body, all have their origins in the stars, and now, in this silent moment, you are a part of it all. The universe is, in essence, infinite. Every night, when we look up at the stars, we are seeing only a small fraction of the vastness that surrounds us. Our human minds, bound by the constraints of time and space, can only comprehend a sliver of what truly exists. Every star, every galaxy, every black hole, and every nebula is just a tiny glimpse into a world we cannot fully experience. It is a reminder that no matter how far we reach, we will never truly touch the edges of the cosmos. Within our own galaxy, the Milky Way, there are more than 100 billion stars. That number, though staggering, is just the beginning. Each of those stars has its own story, its own place in the grand cosmic dance. Many of these stars are far larger than our own sun. They burn with incredible intensity, their light traveling across the void, sometimes for millions or even billions of years, to reach our eyes. And yet, despite the vast distances, every time we gaze upon them, we are witnessing a moment in time that has already passed, a flash of light that began its journey long before we were born. The stars are not merely distant points of light. They are the very building blocks of the universe. Some stars, like our Sun, are born in vast clouds of gas and dust, their birth a slow, gradual process that takes millions of years. Other stars are born in the intense heat of stellar nurseries, where the temperature reaches thousands of degrees. And once a star has burned through its fuel, it will eventually die, often in a spectacular explosion called a supernova. These explosions release an incredible amount of energy, scattering heavy elements across space, elements that will one day form new stars, planets, and even life itself. Yet, even as we gaze upon the stars, we know that we are seeing only a fraction of the universe. For all its size, the visible universe accounts for only a small percentage of what actually exists. In fact, we can only see about 5% of the universe. The remaining 95% is made up of dark matter and dark energy, mysterious substances that cannot be detected by the human eye or by any current technology. These unseen forces, though invisible to us, are the key to understanding the universe's behavior. Dark matter is believed to be responsible for holding galaxies together, preventing them from flying apart. Dark energy, on the other hand, is driving the acceleration of the universe's expansion, pushing galaxies further and further apart. We cannot see these forces, but we know they are there, shaping the universe in ways that we are only beginning to comprehend. Even more awe-inspiring is the fact that the universe is not static. It is constantly expanding, and as it does, it carries with it the light of ancient stars. The light that reaches us from distant galaxies may have traveled for billions of years to get here. In fact, when we look at the stars, we are not seeing them as they are in the present moment. We are seeing them as they were when the light first left them. That light has traveled across vast stretches of space, crossing incomprehensible distances, to finally reach our eyes. So when we look at the night sky, we are looking not only at the stars, but at the past itself. The light we see has been traveling for millions, if not billions, of years, a silent messenger from another time, another place. The universe is also home to some of the most fascinating and mysterious objects known to science. Black holes. These regions of space are so dense that not even light can escape their gravitational pull. They are the most extreme objects in the universe, bending space and time in ways that challenge our understanding of physics. But black holes are not the cosmic vacuum cleaners they are often depicted as. They do not simply suck up everything around them. Instead, they warp space-time, creating a region where the laws of physics as we know them begin to break down. The closer you get to a black hole, the more extreme the effects become. Time itself slows down, and the fabric of space begins to stretch and twist. This phenomenon is known as gravitational time dilation, and it is one of the most mind-bending concepts in modern physics. As we approach a black hole, time seems to slow. To someone far away, it would appear that an object near the event horizon, the point of no return, would slow down, almost coming to a halt. And yet, for the object itself, time would continue to flow normally. This effect, which has been confirmed by experiments here on Earth, shows just how deeply gravity can alter the flow of time. And it's not just black holes that can alter time. There are other places in the universe, especially near extremely massive objects, where time behaves differently than we experience it here on Earth. It is a humbling reminder that our perception of reality is not universal. It is shaped by the conditions of our own planet. When we look at the stars, we are not only looking at distant points of light. We are looking at the history of the universe itself. Every star we see, every galaxy, is a part of a larger story. And yet, as we marvel at these distant objects, we are reminded that they are far from static. The universe is constantly changing. Galaxies collide, stars are born and die, and black holes grow, swallowing everything in their path. The universe is in a constant state of flux, and we, too, are part of that change. Just as the stars evolve, so too does life on Earth, and our place in the cosmos is forever shifting, expanding, and evolving. The universe is 13.8 billion years old, a vast span of time that is difficult to comprehend. And yet, despite its age, the universe is still young in many ways. The stars continue to burn, the galaxies continue to evolve, and the mystery of the cosmos continues to unfold. As we peer into the night sky, we are not just looking at distant objects, we are looking into the very heart of existence itself. The universe is not just an expanse of space, it is a living, breathing entity, constantly in motion, constantly changing. And as we explore it, we find that there is no end to the wonders it holds, no limit to the beauty and mystery that it offers. And so, as we drift through the vastness of space, we are reminded of the scale of the universe. It is so immense that it is beyond our understanding, and yet we are part of it. We are not separate from the stars, the planets, or the galaxies. We are woven into the fabric of the cosmos, a small but vital part of the grand design. The universe is both humbling and awe-inspiring. It is a place of endless possibility, where the boundaries of what we know are constantly being pushed, and where new mysteries await at every turn. Stars. We look up at them every night, but how often do we stop to wonder about their true nature, their birth, their death? Stars are more than just shining points in the sky. They are the architects of the universe, the engines that drive the formation of galaxies, planets, and even life itself. They live, die, and are reborn in an eternal cycle that stretches across millions and billions of years. And as we observe the stars, we are also witnessing a cosmic dance that reflects the very pulse of existence. Stars are born in the cold, dark regions of space, within vast clouds of gas and dust. These clouds, known as nebulae, are the nurseries of the cosmos, where the raw materials for new stars are gathered. Within these clouds, gravity begins to do its work. Slowly, imperceptibly, the gas and dust particles are pulled closer together, their mutual attraction causing them to compress. As the gas clouds condense under the force of gravity, they begin to heat up. This process, though slow, ignites a chain reaction that eventually leads to the birth of a star. As the gas particles collide and compress, they release energy in the form of heat and light. The pressure within the core of this collapsing gas cloud becomes so intense that hydrogen atoms begin to fuse, releasing vast amounts of energy. This is the birth of a star. The energy produced by this nuclear fusion creates an outward pressure that counteracts the pull of gravity, stabilizing the star and allowing it to shine for billions of years. Our Sun is an ordinary star, a middle-aged star that sits comfortably in the middle of the stellar spectrum. It is neither too large nor too small, but just the right size to support life on Earth. It was born about 4.6 billion years ago from a cloud of gas and dust in the Milky Way galaxy, and it has been shining ever since. In fact, our Sun is in the middle of its life cycle, with about 5 billion years remaining before it runs out of fuel and enters the final stages of its existence. But while it may seem ordinary to us, it is anything but ordinary in the grand scheme of the universe. Our Sun is a relatively young star, and its light and energy are essential to life on Earth. However, not all stars are like the Sun. Stars are born with different masses, and their mass plays a crucial role in determining their lifespan and their ultimate fate. Massive stars, much larger than the Sun, burn through their fuel at a much faster rate. They live shorter lives, but their energy output is much greater. These stars shine brightly, burning through their nuclear fuel in a matter of millions of years, before eventually exploding in a spectacular supernova. This is the violent death of a star, where the energy released during the explosion can outshine an entire galaxy for a brief period of time. When a massive star explodes as a supernova, it can leave behind a dense remnant known as a neutron star or, in the most extreme cases, a black hole. Neutron stars are incredibly dense. with a mass greater than the Sun but only the size of a city. They are so dense that a single teaspoon of neutron star material would weigh billions of tons. Black holes, on the other hand, are regions of space where gravity is so strong that nothing, not even light, can escape. These cosmic behemoths form when the core of a massive star collapses under the weight of its own gravity, creating a point of infinite density known as a singularity. While some stars die in dramatic explosions, others fade away more quietly. White dwarfs are the remnants of stars like our Sun. These stars have exhausted their fuel and can no longer support nuclear fusion in their cores. As a result, they slowly collapse, and their outer layers are shed into space. What remains is a dense, Earth-sized remnant, known as a white dwarf. Over time, the white dwarf cools and fades, eventually becoming a cold, dark stellar corpse. As we look into the sky, we also observe the beauty of binary systems. These are pairs of stars that are gravitationally bound to each other, orbiting around a common center of mass. Binary stars are quite common in the universe, and they often reveal more about the life cycle of stars than solitary stars can. When one star in a binary system begins to age and expand, it can transfer mass to its companion star, altering its evolution. This exchange of material can lead to the formation of exotic objects, such as white dwarfs, neutron stars, or even black holes, depending on the masses of the stars involved. While the most massive stars burn brightly for only a few million years, smaller stars, like our Sun, live much longer lives. The smallest stars, known as red dwarfs, are the longest living stars in the universe. They burn their fuel slowly and steadily, living for tens or even hundreds of billions of years. In fact, some red dwarfs have been burning for far longer than the current age of the universe, and they may continue to shine for many billions of years to come. These stars are incredibly stable, providing a steady source of energy for the planets that orbit them. Stars are not just the sources of light in the universe, they are the very building blocks of everything we know. Every element in our bodies, every element that makes up the Earth, was forged in the cores of stars. The hydrogen and helium that make up most of the universe were created in the Big Bang, but the heavier elements, such as carbon, oxygen, and iron, were formed in the intense heat of stellar fusion. When stars die, they scatter these elements into space, enriching the interstellar medium and providing the raw materials for the formation of new stars, planets, and ultimately, life. In a way, we are all stardust. The atoms in our bodies were once part of a star that lived, died, and exploded, scattering its contents across the universe. Over time, those elements came together to form new stars, planets, and even life. The cycle of life, death, and rebirth that takes place in the hearts of stars is the same cycle that governs our own existence. We are not separate from the stars, we are part of them. As we continue to explore the lives of stars, we begin to understand that they are more than just distant points of light. They are the engines that drive the evolution of the universe. They create the energy, the elements, and the conditions that make life possible. They are the cosmic storytellers, their light carrying the history of the universe with it as it travels across the void. The next time you look up at the stars, take a moment to reflect on the vast journey they have taken. The light you see has traveled across the vastness of space, crossing unimaginable distances to reach your eyes. It is a message from the past, a whisper from a time long ago. And as you gaze upon them, remember that you are not just looking at distant objects, you are looking at the very essence of the universe itself. Each star is a chapter in the story of existence, and we are all part of that story. As we continue our exploration of the cosmos, we come to one of the most intriguing and captivating aspects of the universe: the planets. These are the bodies that orbit stars, from the familiar planets of our solar system to the distant and often mysterious exoplanets circling distant stars far beyond our reach. Each planet holds its own secrets, its own mysteries, and its own unique characteristics. Some are well known to us, while others remain shrouded in mystery, waiting to reveal their astonishing qualities. Let's begin with Venus, the second planet from the Sun, often called Earth's sister planet due to their similar size and composition. But while Venus may seem like our twin, it behaves in ways that are far from familiar. One of the most striking features of Venus is that it rotates in the opposite direction from most of the other planets in our solar system. This means that if you were standing on the surface of Venus, the Sun would appear to rise in the west and set in the east, in contrast to the way we experience it here on Earth. Venus' unusual rotation is likely the result of a violent collision with another celestial body early in its history, a reminder that the universe is full of unexpected twists and turns. Now, let's travel to 55 Cancri e, an exoplanet located over 40 light-years from Earth. This planet is a real marvel, for it experiences a weather phenomenon that is unlike anything we encounter in our own solar system. On 55 Cancri e, the temperatures are so high that it rains liquid iron. Imagine standing on a planet where the air is thick with the scent of molten metal, and massive droplets of iron fall from the sky, crashing into the surface below. This extreme world is a reminder of how diverse the environments of other planets can be, with conditions that defy everything we know about weather here on Earth. Moving closer to home, let's visit Mars, the red planet. Mars has long captured our imaginations, and it continues to surprise us with its many mysteries. One of the most striking features of Mars is its enormous mountain, Olympus Mons, which stands 3 times higher than Mount Everest, the tallest mountain on Earth. This gigantic shield volcano spans over 370 miles, 600 kilometers, across, and its summit towers nearly 69,841 feet, 21,287 meters, above the surrounding plains. It is by far the largest volcano in our solar system and serves as a reminder of the immense geological activity that can occur on distant worlds. Meanwhile, Jupiter, the largest planet in our solar system, has long been a subject of fascination. While Jupiter's most famous feature is its Great Red Spot, a massive storm that has been raging for over 300 years, the planet has many more secrets to reveal. Jupiter has its own rings, although they are much less prominent than those of Saturn. These faint rings are composed mainly of dust particles and small rocks, but they still contribute to the planet's immense beauty. Jupiter's storm systems, including the Great Red Spot, are some of the most violent and complex weather systems in the entire solar system. Winds within this storm can reach speeds of over 400 miles per hour, 640 kilometers per hour, and its red hue continues to mystify scientists. This ever-present storm, surviving for centuries, is a reminder of the power and unpredictability of the gas giants that dominate the outer reaches of our solar system. Speaking of gas giants, Saturn is another planetary wonder, famous for its stunning rings, which are composed of ice and rock particles. But Saturn has more to offer than just its rings. At its poles, Saturn exhibits giant, spinning whirlwinds that resemble enormous gears. These polar vortices are unlike anything seen on Earth, and they add to Saturn's mystique as a planet of strange, otherworldly beauty. These enormous, rotating storms extend far into the planet's atmosphere and provide a glimpse into the dynamic nature of Saturn's weather systems. Saturn's rings and polar weather patterns remind us that even the most familiar planets are capable of surprising us with their hidden wonders. Not far from Saturn, we find the icy dwarf planet Pluto, which has fascinated scientists and stargazers alike. While Pluto is no longer officially classified as a planet, it still holds a special place in our hearts. One of the most intriguing aspects of Pluto is its orbit. Unlike the other planets in our solar system, which orbit the Sun in relatively circular paths, Pluto's orbit is elliptical, meaning it sometimes brings the dwarf planet closer to the Sun than Neptune. In fact, there are times when Pluto is actually closer to the Sun than Neptune, though their orbits are carefully aligned to prevent them from colliding. This unusual orbit is just one of the many peculiarities that make Pluto a fascinating object of study. Now let's focus on Saturn's moons. which have become a prime target for exploration in recent years. Saturn has dozens of moons, some of which are quite extraordinary. Take Enceladus, for example. This small, icy moon has an internal ocean beneath its frozen surface. This hidden water, combined with the geysers that shoot plumes of water and ice into space, makes Enceladus one of the most exciting places to search for signs of life beyond Earth. The subsurface ocean on Enceladus is just one example of the hidden worlds that lie beneath the icy exteriors of moons and planets. These secret oceans might hold the key to understanding life in the universe, and might even harbor life forms far different from anything we know. Turning our attention back to Earth, we find that our planet is unique in many ways, not just in its ability to support life but in its delicate balance of forces. One of the most important features of Earth is its magnetic field, which shields us from harmful solar radiation and cosmic rays. This invisible force field is generated by the movement of molten iron in Earth's core, and it helps protect life on Earth by deflecting charged particles from the Sun. Without this protective barrier, the radiation from the Sun would strip away our atmosphere and make life impossible. The magnetic field is a reminder of the delicate balance that allows life to thrive on our planet and the powerful forces that shape our environment. Finally, let's consider the process of planet formation itself. Planets, like stars, do not appear overnight. Their formation takes millions of years. It all begins with the dust and gas that surrounds a young star, known as the protoplanetary disk. Over time, this material clumps together, forming larger and larger bodies through a process known as accretion. These bodies continue to collide and merge, eventually forming the planets we see today. This slow, methodical process is a reminder that the most beautiful and complex objects in the universe are often the result of slow and steady work. Just as stars take millions of years to form, so too do the planets. It is a testament to the power of time and patience in the cosmic dance. As we move through the universe, we encounter a never-ending array of wonders. Each planet, each moon, each orbiting body holds its own unique secrets, waiting to be discovered. From the swirling gases of Jupiter's storms to the icy oceans of Enceladus, from the molten iron rains of 55 Cancri to the quiet, steady heartbeat of Earth's magnetic field, the planets are as diverse and mysterious as the stars themselves. The universe is a place of constant discovery, where every new revelation brings us closer to understanding the cosmic forces that shape our existence. Tonight, as we ponder these astonishing facts, let us remember that we are not just observers of the universe. We are part of it. Every atom in our bodies was once forged in the heart of a star, and every planet we study is a part of the same cosmic journey. We are connected to the universe, not just through the light we see in the night sky, but through the very fabric of our being. The planets are not merely distant worlds. They are our cousins in the grand family of the cosmos, each one unique, each one special. As we explore them, we learn more about ourselves and our place in the universe. The universe is a realm of mysteries so profound and perplexing that they stretch the limits of our understanding. Among the most fascinating and mind-bending objects in the cosmos are black holes. These enigmatic entities are not just places where matter is swallowed whole, they are the very fabric of reality distorted, shaping the flow of time and space. As we embark on this section of our journey, we'll explore the incredible wonders of black holes, quantum physics, and the hidden forces that govern the universe. Let's begin with black holes, those cosmic giants whose gravity is so intense that not even light can escape their grasp. Black holes are often described as vacuum cleaners of the cosmos, devouring everything in their path, but this oversimplifies their true nature. Black holes are far more mysterious and complex. They do not simply suck in everything around them, instead, they warp and twist the very fabric of space-time itself. In essence, a black hole is a region of space where gravity is so strong that it bends the fabric of space-time to an extreme degree. As matter falls into a black hole, it becomes trapped in a point of infinite density, known as a singularity. This singularity is where the laws of physics as we understand them break down, and the very concepts of time and space lose their meaning. It is a place where reality itself is stretched to its limits, and where the rules of the universe are rewritten. A black hole's event horizon, the boundary beyond which nothing can escape, marks the point of no return. Once something crosses this threshold, it is lost forever, consumed by the relentless pull of gravity. What makes black holes even more fascinating is that they can warp space and time around them. This warping of space-time is not just a theoretical idea but a phenomenon that has been observed and confirmed through various experiments. Near a black hole, time itself slows down. This effect is known as gravitational time dilation, and it happens because the immense gravity of a black hole stretches the fabric of space-time. To someone far away from the black hole, an object falling toward it would appear to slow down as it approaches the event horizon, with time seeming to come to a standstill. For the object itself, however, time flows normally. It's a mind-bending concept. The very flow of time, the most fundamental aspect of our reality, is altered by the presence of a black hole. Most black holes are found at the centers of galaxies, where they grow to become supermassive black holes. These giants are millions, even billions, of times the mass of our Sun. Supermassive black holes play a key role in the structure and behavior of galaxies. They are not merely passive entities, they actively influence the evolution of their host galaxies. The incredible gravitational pull of these supermassive black holes can shape the orbits of stars, control the flow of gas, and even trigger the formation of new stars. In many ways, they are the beating hearts of galaxies, dictating their growth and movement. But black holes are not just a feature of galaxies, they may also exist on a much smaller scale. Microscopic black holes are a theoretical concept in quantum physics. These tiny black holes could exist at the quantum level, where the laws of physics are not as we know them. On this incredibly small scale, the normal rules of gravity and space-time break down, allowing for the existence of black holes that are as small as a subatomic particle. These black holes would be invisible to us, as their mass would be so small that their gravitational pull would be negligible. However, their very existence could provide insights into the relationship between quantum mechanics and general relativity, two pillars of modern physics that have yet to be reconciled. Now, let us turn our attention to the extreme conditions that exist on some planets in the universe. While Earth is a cradle for life, there are worlds out there that experience temperatures and pressures far beyond what we can imagine. On planets like 55 Cancri, an exoplanet located about 40 light-years away, the conditions are so extreme that it rains molten iron. The surface of this planet is an inferno, where the heat is so intense that metals vaporize and condense as liquid iron storms. These storms rage across the planet, creating a fiery spectacle that is completely alien to our world. The atmosphere of this planet is thick and toxic, making it an inhospitable place for life as we know it, yet it's a reminder that the universe is full of extremes. But even on planets like Earth, the forces at work are extraordinary. The Earth's magnetic field protects us from the harmful radiation emitted by the Sun. This invisible shield is created by the movement of molten iron in the planet's core and is one of the most important forces that make life possible on our planet. Without this magnetic field, solar radiation would strip away our atmosphere, leaving the surface of the Earth exposed to the full force of the Sun's energy. The magnetic field is a constant reminder of how delicate the balance is that allows life to thrive on our planet. While we have explored the cosmos in search of the most extreme conditions, there are still unseen forces that govern the universe. One of the most mysterious of these forces is dark matter. This invisible substance makes up about 27% of the universe, yet it cannot be detected by any of our current instruments. We cannot see dark matter, nor can we interact with it directly. However, we can observe its effects on the motion of galaxies and other celestial bodies. Dark matter acts like a cosmic glue, holding galaxies together and preventing them from flying apart. It is an invisible force that shapes the structure of the universe, yet remains a complete mystery. Alongside dark matter, there is also dark energy, a mysterious force that seems to be causing the universe to expand at an accelerating rate. While we can't see dark energy, we can measure its effects. It is thought to make up about 68% of the universe, and its influence is felt in the way galaxies move apart from each other. Dark energy is responsible for the accelerating expansion of the universe, pushing galaxies farther and farther away from each other. It is a force that is invisible and intangible, yet it governs the very fabric of space-time itself. As we delve deeper into the strange world of quantum mechanics, we encounter one of the most perplexing and awe-inspiring phenomena in modern physics: quantum entanglement. This strange and mysterious phenomenon occurs when two particles become linked in such a way that the state of one particle is directly related to the state of the other, no matter how far apart they are. This means that changes to one particle can instantaneously affect the other, even if they are light years apart. Quantum entanglement challenges our traditional understanding of space and time, as it suggests that particles can be connected in ways that transcend the limits of distance. This phenomenon has been experimentally verified, yet its implications are still being debated by physicists, as it seems to defy the laws of classical physics. As we explore the wonders of black holes, quantum physics, and the hidden forces of the universe, we are reminded that the cosmos is not just a collection of stars, planets, and galaxies. It is a living, breathing entity, constantly shifting and changing, constantly revealing new mysteries. From the bending of space and time near black holes to the unseen forces of dark matter and dark energy, the universe is a place of constant discovery. Every new revelation brings us closer to understanding the deepest truths of existence. The universe is an intricate and dynamic dance of energy and light, a vast expanse where forces both visible and invisible shape the cosmos in ways that are beyond our understanding. The energy that courses through the universe is not just a passive backdrop to the stars and galaxies. It is the force that powers the very existence of everything we know. From the distant light of stars that has traveled billions of years to reach us, to the invisible forces like dark energy that drive the expansion of the universe, cosmic energy is both the heartbeat and the mystery of the cosmos. Let's begin our journey by considering light itself, the most fundamental form of energy that connects us to the universe. Light, as we know it, has an almost magical quality. It travels across the vast reaches of space at an incredible speed, covering distances of millions and billions of light years. The light from even the closest stars takes years to reach us, and from stars that are farther away, it can take millions or even billions of years. When we look up at the stars, we are seeing light that has traveled across the cosmos, carrying with it the story of a distant past. It's humbling to think that, when we look at the stars, we are actually looking at history, light that began its journey long before our own planet even existed. For instance, when you gaze at the light from our nearest stellar neighbors, such as Alpha Centauri, you're not just observing a star in real time, but rather seeing its light as it was years ago. Some of the light we see from more distant stars may have traveled through the universe for billions of years, carrying with it a glimpse of an ancient time. The vastness of time and space itself is woven into the light that we witness, reminding us that we are, in a sense, time travelers, looking back at the universe as it was, not as it is. In contrast to the light we see with our eyes, cosmic rays are another form of cosmic energy that travel through space at nearly the speed of light. These highly energetic particles come from distant corners of the universe, carrying with them immense amounts of energy. While most cosmic rays pass through space without incident, some of them do penetrate the Earth's atmosphere, reaching the surface. Fortunately, our atmosphere acts as a protective shield, absorbing these cosmic rays before they can cause harm. Yet, even as they bombard us from space, they offer clues about the most energetic phenomena in the universe, including supernovae and black holes. The next time you step outside and feel the sunlight on your skin, remember that cosmic rays are also part of the same cosmic exchange, reaching you, though you cannot see them. Now, let us delve into one of the most fascinating and mysterious sources of energy in the universe: black holes. Black holes, as we've learned, are not simply massive objects that suck in everything around them. They are incredible sources of energy. The most powerful bursts of energy in the universe occur at the centers of black holes. As matter falls into a black hole, it is compressed and heated to unimaginably high temperatures, releasing enormous amounts of energy. This energy is emitted in the form of radiation, and it can travel across space, carrying with it information about the inner workings of the black hole. Black holes, then, are not just places of darkness, they are powerful engines of energy, releasing radiation and matter as they consume their surroundings. It's this energy that helps astronomers study the deepest regions of space. We are all cosmic travelers. While we may not always think of it in these terms, the Earth is in constant motion as it orbits the Sun. Every day, as the Earth spins on its axis, it carries us along at incredible speeds, moving through space as part of our journey around our star. This motion, this constant revolution, is part of the larger rhythm of the cosmos. The Earth is not stationary, it is part of an endless dance through space, circling the Sun at an average speed of 67,000 miles per hour, 107,000 kilometers per hour. And, as the Earth orbits the Sun itself moves through the Milky Way galaxy, carrying our solar system with it. We are, each of us, part of this cosmic journey, passengers on a planet that is forever in motion through the vast expanse of space. This cosmic dance, the movement of the planets and stars, is driven by energy. Energy is the force that makes everything in the universe move and change. It is present in the light of the stars, in the heat of distant galaxies, and in the expansion of the universe itself. The universe is constantly evolving, constantly expanding, and it is energy that propels this motion. The very fabric of the universe is woven from the energy that flows through it, shaping galaxies, stars, and planets, and driving the processes that make life possible. As the universe expands, the energy of the cosmos increases. This is a profound and humbling thought. The universe itself is growing, and in doing so, it is creating more energy. This expansion is driven by a mysterious force called dark energy, which makes up about 68% of the universe. Dark energy is thought to be responsible for the accelerating expansion of the universe. While we cannot see dark energy, we can measure its effects on the movement of galaxies. Dark energy is pushing galaxies farther and farther apart, speeding up the expansion of the universe. It is a force that works invisibly and relentlessly, a quiet driver of the universe's vast, ongoing transformation. Another essential form of energy in the universe is nuclear fusion. This is the process by which stars generate energy. In the core of a star like our Sun, hydrogen atoms are fused together under immense pressure and temperature, creating helium and releasing vast amounts of energy in the process. This energy is what powers the Sun and provides light and heat to our planet. Without nuclear fusion, stars would not shine, and life on Earth would not exist. The fusion process is a remarkable example of how energy can be created from the simplest elements, a process that has been occurring in the hearts of stars for billions of years. In the early stages of the universe, the cosmos was filled with plasma, a hot, dense state of matter. After the Big Bang, the universe was too hot for atoms to form, and it was filled with this high-energy plasma. As the universe cooled, atoms began to form, and matter as we know it began to take shape. This cooling process eventually allowed stars, galaxies, and planets to form. But the energy of the universe, the heat left over from the Big Bang, still lingers in the form of cosmic microwave background radiation. This faint, invisible glow fills the universe and offers us a glimpse into the early stages of the cosmos, a snapshot of the universe when it was just a few 100,000 years old. Alongside the light and heat of stars, we also encounter the invisible cosmic microwave background radiation, a faint, omnipresent glow that fills the universe. This radiation is a remnant of the Big Bang, the birth of the universe itself. The discovery of this background radiation provided the final piece of evidence for the Big Bang theory and helped scientists understand the early evolution of the cosmos. Though we cannot see this radiation with our eyes, it is present everywhere, a constant reminder of the universe's beginning. Finally, let's explore X-ray radiation. X-rays are a form of high-energy radiation that comes from some of the most extreme and violent phenomena in the universe. One of the most important sources of X-ray radiation is black holes. When matter falls into a black hole, it is heated to incredibly high temperatures as it spirals into the event horizon. This intense heat produces X-rays, which can travel across space and be detected by telescopes. These X-ray emissions allow astronomers to study the behavior of black holes, their accretion disks, and the powerful jets of matter that some black holes eject. X-ray radiation, in this way, becomes a powerful tool for exploring the deepest, most mysterious regions of the universe. In the vast and mysterious expanse of the universe, energy flows in countless forms, from the light of distant stars to the powerful bursts of radiation emitted by black holes. These forces shape the cosmos, driving the expansion of space and fueling the birth and death of stars. From the cosmic microwave background that traces the origins of the universe to the intense heat of stars burning millions of miles away, energy is the force that binds the universe together. As we continue to explore, we discover that energy, in all its forms, is the lifeblood of the cosmos, ever-changing, ever-expanding, and ever-present. When we look up at the night sky, we see the stars. But what we often fail to grasp is that those stars are not scattered randomly across the heavens. They belong to vast, complex structures known as galaxies. These magnificent cosmic entities are the building blocks of the universe, each one containing billions, even trillions, of stars, planets, and other celestial objects, bound together by gravity and stretching across vast distances that we can hardly imagine. Our journey into the universe's galaxies will take us to the farthest reaches of space, where we will discover their intricate beauty, complex relationships, and their critical role in the cosmic tapestry. In the immense expanse of the universe, there are billions of galaxies, each containing an unimaginable number of stars. This sheer number of galaxies makes the universe feel infinite, and indeed, it may very well be. When we look out into the vast darkness of space, we see just a fraction of the cosmos, a tiny fraction of the galaxies that stretch out in all directions. Some of these galaxies are so far away that their light takes billions of years to reach us, offering us a glimpse into the distant past, a window into the ancient moments when the universe was still young and forming. The relationships between galaxies are as dynamic as the stars within them. Galaxies can merge and collide in a cosmic dance that can take billions of years to complete. This process, known as galactic mergers, leads to the creation of entirely new galaxy structures. Imagine the collision of two massive galaxies, their stars and gas clouds swirling and intermingling, eventually forming a single, more massive galaxy. These mergers are often violent, creating intense bursts of star formation and sometimes even triggering the growth of supermassive black holes at the centers of the new galaxies. The interaction between galaxies is a testament to the immense forces at work in the universe, where even the most stable of structures are subject to change and transformation over time. Our very own galaxy, the Milky Way, is a spiral galaxy, with vast arms of stars, gas, and dust spiraling out from a dense, star-filled center. The Milky Way is home to our Sun, our solar system, and countless other stars and planetary systems. It is a sprawling, majestic galaxy that holds within it the stories of billions of years of cosmic history. As one of the most well-studied galaxies, the Milky Way reveals the beauty of spiral galaxies, with their elegant, sweeping arms and their central bulge, which contains a dense concentration of stars. The Milky Way is a shining example of the dynamic, evolving nature of galaxies, constantly evolving and interacting with other cosmic structures. Beyond our own galaxy lies Andromeda, the closest large galaxy to the Milky Way. The Andromeda Galaxy is an enormous, spiraling galaxy, and it is on a slow, inevitable collision course with the Milky Way. In about 4 billion years, the two galaxies will collide, merging into a new, larger galaxy. This event will be a monumental one, reshaping the structure of both galaxies and triggering intense bursts of star formation. While our Sun and solar system will likely survive the collision, the night sky will look dramatically different. The merging of the two galaxies will be a slow process, taking billions of years, but it will be one of the most profound events in the history of the universe. Galaxies come in a variety of shapes and sizes. While the Milky Way and Andromeda are spiral galaxies, other galaxies take on different forms. Elliptical galaxies, for example, are more rounded and smooth in appearance, with older stars and little interstellar gas and dust. These galaxies tend to be less active than their spiral counterparts, with fewer new stars being born. On the other hand, irregular galaxies have no defined shape and are often chaotic in their structure. These galaxies can be small or large, and they may have undergone recent interactions or collisions that have disrupted their original form. The diversity of galaxy shapes reminds us of the immense variety that exists in the universe. No two galaxies are exactly the same, each one is a unique expression of the forces that shape the cosmos. At the very heart of many galaxies lies a supermassive black hole, a cosmic behemoth that can be millions or even billions of times more massive than our Sun. These black holes play an essential role in the structure and evolution of their galaxies. The gravitational pull of a supermassive black hole is so strong that it influences the movement of stars, gas, and dust throughout the galaxy. In some cases, the intense energy released by material falling into a black hole can cause the galaxy's central region to shine brightly, often outshining the rest of the galaxy. These supermassive black holes are not just passive objects, they shape the dynamics of their galaxies, sometimes even triggering bursts of star formation or supernova explosions as matter is pulled into their depths. The relationship between galaxies is not limited to collisions and mergers. On a larger scale, galaxies are part of a vast cosmic web, a structure of galaxies connected by filaments of dark matter and gas. This web stretches across the universe, linking galaxies together in a giant network that spans the entire observable cosmos. This cosmic structure is sometimes referred to as the cosmic spider web because of the way the galaxies are connected in long, branching filaments. The existence of this web is one of the most profound discoveries in modern cosmology, showing that galaxies do not exist in isolation. They are part of a much larger, interconnected system, bound together by the invisible threads of dark matter. Speaking of dark matter, many galaxies are thought to contain dark matter, a mysterious, invisible substance that makes up a large portion of the mass in the universe. Dark matter cannot be seen directly, but its presence is inferred through its gravitational effects. Galaxies with high concentrations of dark matter experience stronger gravitational forces, which helps explain why some galaxies appear to have more mass than we can observe. Some galaxies, however, may be devoid of dark matter, a discovery that has puzzled scientists. The interaction between visible and dark matter is one of the great cosmic mysteries, and understanding it may reveal more about the fundamental structure of the universe. As the universe continues to expand, galaxies are moving farther apart, carried by the stretching of space itself. The expansion of the universe means that, over time, galaxies will continue to drift away from one another, making the universe seem more and more vast. In the distant future, galaxies that are now visible to us may no longer be observable, as they will be too far away for their light to reach us. This expansion is driven by the mysterious force known as dark energy, which accelerates the expansion of the universe, causing galaxies to recede from one another at an increasing rate. Finally, some galaxies are home to massive nebulae, vast clouds of gas and dust where new stars are born. These nebulae are the cosmic nurseries where the raw materials for star formation are gathered. In these regions, the conditions are ripe for new stars to ignite, and over millions of years, these newborn stars will shine brightly, casting their light across the galaxy. Some of the most famous nebulae, such as the Orion Nebula, are visible to the naked eye, glowing with the energy of new stars and providing a glimpse into the ongoing creation of the cosmos. Nebulae are not just beautiful, they are the lifeblood of galaxies, the places where new life is created from the dust and gas of the old. The study of galaxies reveals just how much there is to learn about the universe. Each galaxy, with its stars, black holes, nebulae, and dark matter, tells a unique story of cosmic evolution. From the grand collisions of galaxies to the hidden dark matter that shapes their structure, galaxies are the heart of the cosmos. And as we explore them, we come closer to understanding not only the universe's past but also its future. The vast, interconnected network of galaxies is a constant reminder that we are part of something much larger than ourselves. In the grand tapestry of the cosmos, we are mere specks, floating within one galaxy among billions. And yet, we are connected to it all, to the stars, the planets, the galaxies, and the unseen forces that bind them together. As we peer deeper into the cosmos, we continue to uncover the mysteries that lie within, one galaxy at a time. The universe is a grand, majestic expanse that has been unfolding for over 13.8 billion years. But even as we stand at the precipice of understanding the cosmos, it's humbling to remember that the universe is not a static entity, it is a place of constant motion, evolution, and transformation. The future of the universe, like its past, is filled with wonder and mystery, and the forces at play will determine the fate of everything within it, from the smallest particles to the most massive galaxies. As we delve into the profound truths of the universe's future, we are reminded that the cosmos is an ever-changing, ever-expanding tapestry, and we are but a fleeting part of it. The universe will continue to expand, just as it has since the moment of the Big Bang. But this expansion won't continue indefinitely at the same rate. In fact, the rate of expansion is accelerating, driven by the mysterious force known as dark energy. Dark energy, which makes up about 68% of the universe, is pushing galaxies apart, causing the universe to stretch like an ever-growing balloon. As the universe continues to expand, galaxies will move farther and farther from one another, and the space between them will become vast, cold, and empty. In the distant future, the night sky will appear very different from the one we see today, as galaxies will be so far apart that they will no longer be visible to each other. Over the course of billions of years, the universe will become a place of solitude, its stars isolated in the expanding void. As stars age and run out of fuel, the fate of these cosmic giants will play a central role in the future of the universe. Our Sun, a relatively average star in terms of size and brightness, will eventually burn through its nuclear fuel. As this happens, the Sun will expand into a red giant, a swollen version of itself that will consume the inner planets of the solar system, including Mercury, Venus, and perhaps even Earth. The Sun will shed its outer layers, creating a stunning planetary nebula, while the remaining core will collapse into a white dwarf. Over the course of billions of years, the white dwarf will cool and fade, becoming a cold, dark remnant of the once brilliant star it once was. But not all stars will follow this path. Some, much more massive than our Sun, will end their lives in a far more dramatic fashion, exploding in a supernova. These massive explosions can create black holes or neutron stars, both of which are among the most extreme and fascinating objects in the universe. One of the most awe-inspiring phenomena in the universe occurs when black holes collide. These invisible giants, with their immense gravitational pull, can merge together, releasing an unimaginable amount of energy. When two black holes collide, they create gravitational waves, ripples in the very fabric of space-time that travel across the universe at the speed of light. These waves were first detected in 2015, confirming a key prediction of Einstein's general theory of relativity. The energy released during such a collision is so immense that it can be detected by instruments on Earth, offering us a rare glimpse into the deepest, most extreme processes of the cosmos. The collision of black holes is a reminder that even in the most far-reaching corners of the universe, matter and energy are constantly interacting, changing, and evolving. The future of the universe is not just about the fate of individual stars or galaxies, but also about the ultimate balance of energy. Currently, the universe is in a state of dynamic equilibrium, with energy constantly being exchanged and transformed. However, over the long term, it is possible that all the energy in the universe could eventually be equilibrated. This process, sometimes referred to as the heat death of the universe, would result in a state where all matter and energy are evenly distributed, and no significant processes or changes occur. This distant future, where the universe reaches its final stage, is both fascinating and somewhat sobering. It suggests that the universe, in its infinite complexity, may one day settle into a state of perfect stillness, with no movement, no change, just an endless, static expanse. And yet, even as the universe cools and its stars burn out, there may be new forms of existence that await discovery. Parallel universes, alternate realms beyond our own, could exist, though they are currently beyond our understanding. Some scientists speculate that there could be entire universes with different physical laws, where the rules of time and space are altered in ways that we cannot yet comprehend. These parallel universes may be just beyond our reach, hidden in the folds of spacetime, but their existence challenges our fundamental understanding of reality. The idea that there could be other universes, each with its own unique set of physical laws, is one of the most profound and mysterious possibilities in modern physics. It suggests that our universe is not the only one, and that reality itself may be far more complex than we can imagine. To unlock the mysteries of the universe, scientists are looking deeper into the nature of quantum particles, the building blocks of everything we know. Quantum mechanics is the field of physics that deals with the behavior of particles at the smallest scales, and it holds many surprises. One of the most bewildering aspects of quantum physics is the phenomenon known as quantum entanglement. This strange occurrence happens when two particles become linked in such a way that the state of one particle is directly tied to the state of the other, regardless of the distance between them. This means that when one particle is altered, the other will be altered instantly, even if it is light years away. This phenomenon challenges our understanding of space and time, suggesting that particles can communicate across vast distances without any physical connection. Quantum entanglement hints at a deeper, more interconnected fabric of reality, where the laws of physics may work in ways that transcend our classical understanding. As we continue to explore the universe, the dream of interstellar travel may one day become a reality. Though we are far from having the technology to travel between the stars, the possibility remains tantalizing. If we can develop faster-than-light travel or harness the power of wormholes, we could one day journey across vast distances, exploring distant stars and planets. The idea of traveling to other star systems is not merely science fiction, it is a possibility rooted in the laws of physics, and it is something that future generations may one day achieve. Imagine journeying to Alpha Centauri, the closest star system to our own, or even reaching distant exoplanets in far-off galaxies. The future of space travel is limited only by our imagination and technological progress, and the possibilities are endless. As we reach the limits of our understanding, we also encounter new dimensions of reality. The nature of time itself may not be the only measure of existence. There may be additional dimensions of space and time that we have yet to discover. Scientists are constantly exploring the possibility that our universe is not just a three-dimensional space, but one with more dimensions that remain hidden from us. The discovery of these extra dimensions could unlock entirely new laws of physics, opening up new ways of understanding gravity, energy, and matter. It is an exciting possibility that challenges the very foundation of what we know about the universe. As we contemplate the future of the universe, we are reminded that we are only at the beginning of our journey. The cosmos is vast, complex, and constantly changing, and our understanding of it will continue to evolve. The forces of the universe, from the birth and death of stars to the mysteries of quantum mechanics, shape the reality we live in, and will continue to shape the future of all existence. And as we look to the stars, we realize that we are part of this grand, unfolding story, a fleeting moment in the eternal dance of the universe. Our journey, though small, is connected to the vast, cosmic journey of all that is. As we come to the end of this journey through the vast, endless expanse of the universe, let us take a moment to pause and reflect on what we've discovered. We've ventured into the depths of time and space, explored the birth and death of stars, marveled at the incredible forces shaping galaxies, and pondered the mysteries of quantum mechanics. The universe, in all its complexity and beauty, continues to unfold before us, and though there is still so much we don't understand, we are connected to it in ways that transcend our comprehension. Take a deep breath. Let the vastness of the cosmos sink in, not as something distant and unreachable, but as something intimately tied to who we are. The universe, in all its wonder, is not just a collection of stars and galaxies, it is the very fabric of our existence. Every atom in our bodies, every breath we take, is connected to the stars that came before us, to the cosmic events that shape the universe. We are part of something far greater than ourselves, and that knowledge fills us with both awe and peace. As we look to the future, we are reminded that the universe is a place of endless discovery. There is so much more to learn, so many more mysteries to unlock. The stars above us, the galaxies that stretch beyond our reach, and the forces that govern it all continue to whisper their secrets to those who are willing to listen. And we, as explorers of the cosmos, are just beginning our journey. So, as you close your eyes, remember that you are part of this great cosmic story. In the stillness of the night, the universe is still expanding, still evolving, still revealing its wonders. With each passing day, we move closer to understanding more of what lies beyond our grasp. And with each discovery, we find new questions to ask, new mysteries to explore. May the knowledge of the cosmos bring you peace and wonder, and may it inspire you to continue seeking, to continue exploring, and to continue dreaming. The universe is out there, waiting to be understood, and you are a part of it, now and forever. Thank you for joining us on this peaceful journey through the stars. Until we meet again, remember to look up, marvel at the wonders around you, and never stop exploring.